Good morning, everyone. Today's video is about using Venn diagrams to represent sets, subsets, and set operations. Now, before I give you examples, let me just show you or tell you a bit of history about diagrams and specifically the Venn diagram. Diagrams in general make mathematics easier because they help us to see the whole situation or the whole picture at a glance. Back then, there was an English mathematician named John Venn, and during his times, he used diagrams to represent sets. That's why the Venn diagram is named after him, and it's very helpful for us to use this, especially in representing sets, and later on in solving problems involving sets. Now, let's have this example about universal set. So this larger set is called the universal set, and it is usually given by the symbol E. Now, in a Venn diagram, the universal set is generally drawn as a large rectangle, as you can see here. And then other sets, now in this particular example, you have a subset that is represented by a circle. And that's a subset of all the letters of vowels, or all the vowels rather. Okay? Now, the next one that we have here is the representation of subset in a Venn diagram. So when we know that S is a subset of T, we place the circle representing S inside a circle representing T. So T is our universal set here. And then we have a subset 0, 1, and 2. So that's this one, and it's being represented by a circle. And all of the elements in that subset are there. And of course, those elements of subset is obviously part of the universal set 0, 1, 2, 3, and 4. All right. Let's go to the next one, and here what we have is the complement of a set. Now, how do we represent that or illustrate that as a Venn diagram? But before that, let me just explain to you what they mean by complement of a set. Now, suppose that a suitable universal set E has been chosen. The complement of a set S is the set of all elements of E, which is the universal set that are not in S. Okay, now the complement of S is written as S prime. Okay, now here we have an example. For example, E is the universal set and it consists of all the letters in the English alphabet. And then we have a subset V, which is the letters of the vowels. Then the complement of V is equal to the consonants. Now, of course, as you can see here, we don't have a Venn diagram, and it's hard for us to imagine and picture the image of what I'm explaining to you. But given a Venn diagram, it's easy. So we have here E, which is the universal set, and these are the letters of the English alphabet. And then we have a subset V, which are the vowels. And if the question is, what's the complement of V? Well, that's easy. That's just the universal set minus the vowels, which is equal to the consonants. And that's all the letters outside of the subset V. All right, let's go to the next one. And here what we have is the intersection of two sets. So the intersection of two sets A and B consists of all elements belonging to A and to B. This is written as A intersection B. Now, for example, some musicians are singers, and some play an instrument. Now, we can say that there are people or there are singers but who cannot play instruments, and also we can also say that there are people who can play musical instruments but they cannot sing. But there are also a lot of people that can sing and play musical instrument at the same time. Okay, now here's an example using numbers. So let's say we have a set M 1, 2, 3, 4, and 5, and we have a set N 4, 5, 6, and 7. So the intersection of M and N, the elements of those common for M and they are the numbers 4 and 5. So using Venn diagram, we can clearly see the intersection of set M and set N. And the intersection are the numbers 4 and 5. All right? Okay, so let's go to the next one. And here what we have is the union of two sets. So the union of two sets is a set containing all elements that are in A, B, or both. So this is written as A union B. So that's the symbol for the union. Now here, as you can see, we have again a Venn diagram to represent the concept of union of two sets. So we have a rectangle and we have two subsets, A and B. If we put all those elements together, then we have what we call the union of two sets. All right? Now, in relation to the union of two sets, we also have what we call disjoint sets. Now, disjoint sets or two sets are called disjoint if they have no elements in common. Okay? So, for example, the sets X and Y. So, set X, 1, 4, 7, and 9. Set Y, 2, 3, 6, and 8. They don't have a common element. So, these sets are called disjoint. All right? So, that's it for today. I hope you learned something. And then in my next video, I'm going to show you how to use Venn diagram to solve problems involving sets. Thank you and have a nice day.